look at how we can express correlation. When we look at correlation between association between two variables, x and y, we know that we can express this association in two ways: covariance and correlation. Correlation coefficient is standardized for the gross values by dividing by the standard deviations of x variable and the y variable. But we have to ensure before we undertake the correlation analysis that the two variables have a linear relationship and the variables conform to normality, that is, the parameters of those variables conform to normality. If they do, then we can use the Pearson product moment correlation. But if the two variables do not conform to those assumptions, linearity and normality, then we can use Spearman's rule. We can use Spearman's rule for large samples or Kinder's-Tau for small samples. There's also another option. When the variable's data behavior does not conform to the linearity and normality, we can use bootstrapping technique. So that it can examine for the linearity and normality and do various adjustments. And then when we express the correlation, we can use the confidence intervals, because the confidence intervals are not affected by the data distribution, rather than using the significance levels, because the significance levels are affected by data distribution, because the linearity, especially the normality, can be influenced by the outliers in the data distribution. So when we want to express the confidence interval, we can use the standard error of our estimation, and at 95%, we can multiply that by 1.96 and taking the mean value plus or minus standard error of the estimate into 1.96 will give us the upper and the lower boundary of confidence interval. So when we obtain an association between two variables, we can use for hypothesis testing. For example, we can use the null hypothesis as there is no relationship. And we can test out a directional relationship. Then it is a one-tailed hypothesis. And that directional relationship could be that our observed value is greater than 0, that there is a relationship and it is greater than 0, or there is a relationship and it is less than 0. The second is a two-tailed testing where we don't assume a direction. That means that there is a relationship between the two, but that relationship is not equal to 0. And we are going to test that as when we obtain the correlation coefficient. The correlation coefficient shows the strength of the relationship between the two variables. We can use the correlation coefficient to find the variability between the two variables or the explanation shared by the two variables. To do that, we take the correlation coefficient, the R in lowercase, and square it. Then we use as the capital R square, and that's called the coefficient of determination. We can do this for two variables and extend the correlation coefficient, the strength of the relationship, to determine the shared explanation between the two variables.